Okay, we are moving into Matrix, and something I'm going to have y'all do is do these by hand. We are not putting them in the calculator. So on your quiz, you will have a quiz that you will have to work everything out on paper with 5-1, 5-2, and 6-1. It'll be short. There'll probably be 4 questions on it. So that'll give you plenty of time. So you'll have plenty of time to finish it since you are doing it by hand. So with Matrix, with systems of equations like we were dealing with before, you can translate a system of equations into matrices. So a matrix would be like this. And you just put your coefficients in there as entries. So if it is a 3 variable system, then you will have 3 rows. You'll have 1, 2, 3 rows, and then there'll be 4. And this is there's usually a line down it. And then 4 columns. So it's rows by columns. Okay, so let's just look at this first example. Write the augmented matrix for this system. All you're writing are your coefficients, and make sure they're in order. So see how all of these are x's, these are y's, z's, and then this is equals some number. So we'll transfer this into a matrices. So it'd be 5, -2, -3, 0. So the first column is your x's. 1, 1. There's no z in the second equation, so that'll be a 0, and then 5. Then the next one would be 2, 0, -3, and 4. So when we write it out, we can leave it like that, or we can, we don't have to put that there. Whenever you put it in the calculator, though, when we get to that point, you don't have to put a line or anything like that. It's all the same. Okay, so let's talk about row operations. We can do different operations with our rows. We can multiply a row by a number, add it to a number. We can do all these different operations. So we are just going to write an example. It's going to be 3, 18, -12, and 21. And then 1, 2, -3, 5. -2, -3, 4, and 6. So this is your row 1, this is row 2, this is row 3. So we could do an operation like this, row 1 to row 2. All that means is you are going to exchange them. And row 2 for row 1. So then we could rewrite it, be 1, 2, -3, 5. 3, 18, negative 12, 21. Then nothing happens to row 3. Just stays the same. So now this is our new row 1, this is our new row 2, and our row 3 stayed the same. Okay, so the reason we would want to do these different row operations is so that we can reduce our matrices and actually solve for our variables. And that's what our calculator does whenever we input it in. It does all the magic for you. But I want you to be able to do it without that. So then let's say we want to do 1/3 of R2 to get our new R2. So the only thing you're going to change is row 2. Take 1/3 of it. So I'm going to still write row 1. But I'm going to do 1/3 of row 2. So it'd be 1, 6, negative 4, 7. And then our row 3 also stays the same. Okay, another operation that we could do is we could multiply negative 1 times row 2 and then add it to row 1 to get our new row 2. Or no, our new, I think it's usually mixed up. Let's do it like this. A negative 1 times our row 1 plus row 2 to get our new row 2. The way that it'll be written is like this, and that's going to get your new R2. It won't say arrow R2. It'll just say negative 1 times R1 plus R2. But that means you're replacing that row with the operation that happened to it. So we would do multiply everything on row 1 times a negative. So that'd be a negative 1, negative 2, positive 3, negative 5. And then we're going to add it to row 1. So I'm going to put it directly underneath. 1, 6, negative 4, 7. I'm just adding those individual entries because these are all the same matrix. If we had a different dimension matrix, then we have to change things up when we add them. But here we're just adding the rows. So this would be 0, 4, negative 1, 2. So now we will write our matrix now. So this is 1, 2, negative 3, 5. We keep the exact same R1. The only thing we changed was R2. So it's 0, 4, negative 1, 2. And then row 3 is the exact same. Negative 2, negative 3, 4, and 6. So those are row operations. So let's go ahead and do part 2 on our paper. So I'm going to let you go ahead and do that. Half of R1 is our new R1. So do 2A and 2B. Okay, I'll show you 2A. If we're just doing half of row 1, we're going to replace row 1 with half of it. So it'd be 1, -3, 2, and 5. Everything else would stay the same. Check yours. Okay, and then the next one, 2B, says -3 times row 1 plus row 2. So that means I'm going to multiply -3 times row 1, add it to row 2, and I'm going to exchange my row 2 with this new one. So I first did -3 times my row 1. So I just wrote it out kind of like I would if I was distributing. And then I actually multiplied -3 times every single entry on row 1. And then I added it to row 2. And here are my new entries for row 2. And I rewrote my matrix. Same row 1, same row 3. Row 2 was the one that changed. How'd y'all do? Can I explain anything a little different or anything? The negative? Okay. Yeah, that could change it. Yep, you got to be careful with that. All right. And so we're done with those. So we are going to write some notes on the Gaussian elimination. Hey, y'all are going to have to slow me down on this because I get really excited. I'm a nerd. It's so much fun. Okay, so this is going to help us solve systems. And what our goal is, it is to have 1, and then it could have any numbers here. And then a 0, 1, any numbers here. And then a 0, 0, 1, and any number here. That is our goal. See how this bottom corner is zeros? That's our goal. And then our diagonal, because if we look at it like that with the line separating the equals, the diagonal right here is all ones. So that is our goal. We are going to do row operations to get it to look like this. Okay, y'all ready? So we're going to do number 3. Okay, so if you'd rather write it in your journal, you can. I kind of like that we have the graph paper, so I'm going to write it over here. So I'm going to say example 3. So we have the equation. Let's transfer the equation into a matrix. So it'd be 1, 1, -1, -2, 2, -1, 1, 5, -1, 2, 2, 1. So the first thing you're looking for is in this upper right, you want it to be 1. So that's good. I'm going to check that off. So then our second step would we want this term to be 0. This term right here, we want that to be 0. So we've got to do some kind of row operations multiply, add, subtract, whatever we can to get this to equal 0. So what I think we should do is, see how this is already a -1? This is a +2. But if I change this to a +2 and then I add them together, I would get a 0 right here. That's the only thing I'm worried about, is this 2 to be changed to a 0. So I'm going to multiply 2 times row 3. Then I'm going to add row 2 to get my new row 2. So first thing is multiply 2 times row 3. So -1, 2, 2, 1. Which becomes -2, 4, 4, 2. So I have the 2 times row 3. Now I'm going to add to row 2. So I'm going to put plus my row 2. 2, -1, 1, and 5. Now when I add them, the first entry on row 2 is now a 0. Then we have 3, we have 5, and 7. So this is my new row 2. So let's rewrite it. Row 1 is the same. It hasn't changed. Row 2 is the one that we just found that has a 0 first. And then row 3 is the exact same. Okay, so we've gotten the 1, we got the 0. So the next thing would be to get this 3 to equal 1. Because remember, our goal is to have that triangular look to it. Like this. Some number in those entries. But the 0, this 1, 0, 1, 0, 0, 1, that's our goal. So our next thing that we're looking for is to get this to be a 3. What could I do to row 2 to make that equal to 1? Say that again. Yeah, do 1/3. So we can do 1/3 of row 2 for our new row 2. So I'm just going to rewrite the matrix. Same row 1. But for row 2, if I do 0 times 1/3, I'm still going to have a 0 there. So my whole goal is not to change that 0 from being the 0 anymore. I need to keep that to be a 0. If I added this or multiplied by something, that would change that 0 from being a 0. That's why we're multiplying now. So that'd be 0. Now it's a 1. 5 times 1/3, 5/3. And 7 times 1/3 is 7/3. So now we have a -1, 2, 2, 1. All right, so we're good on row 1 and row 2 being exactly where we want it. So now row 3. I need to get rid of this. And what do I want this entry to be now? A 0. So what could I do to this row to make -1 a 0? We would add 1. -1 plus 1 is 0. So we can just add row 1 to it. So we're going to do row 1 plus row 3 to get our new row 3. So row 1 is 1, 1, -1, -2. And then we have row 3, -1, 2, 2, 1. We're going to add those together. So 1 plus a -1 is 0. 1 plus 2 is 3. -1 plus 2 is 1. 2, -2 and 1 is -1. So we're going to rewrite it again. 1, 1, -1, -2, 0, 1, 5/3, 7/3, and then 0, 3, 1, -1. Okay, I have diagonal 1s, but I don't have a 0 right here on this 3. So I need to be able to multiply or add this 3 to something to make it a 0. So I need a -3. So what could I do to one of these? I wouldn't want to use the first one because if I add that to something, that's going to change my 0 from being the 0. So then I look here and I see that this is a 1. Could I somehow make this 1 be a -3? What could I multiply it by? -3. And then I could add it. So we do -3 times row 2 and add it to row 3. So let's go ahead and multiply row 2 by -3. So this is -3, 0, -3, -5, -7. Then I add it to the row 3 that we have, 0, 3, 1, -1. Okay, so whenever I add it, this becomes 0, this becomes 0, this becomes -4, and this becomes -8. Okay, so we just need to rewrite it now. I'm going to come over here. So this would be our same row 1, same row 2. Row 3 is 0, 0, -4, -8. Okay, we're almost finished. So our last goal is to have this. We want it to be equal 1. What needs to happen to -4 to make it a positive 1? We need to do 1/4 of it, negative, because negative and negative would make it positive. So we're going to do -1/4 of row 3. Because what happens whenever I do -4 times a -1/4? It equals positive 1. So -1/4 times a -4 equals positive 1. And then -1/4 times a -8 equals 2. Okay, so this is 1, 1, -1, -2, 0, 1, 5/3, 7/3, 0, 0, and now it's a 1, 2. Are y'all still with me? Are y'all hanging on? Blank stares. So we have what we wanted. So from this, remember, this is your X column, this is your Y column, this is your Z column. So our last row should tell us one of our solutions, one of our variables. This last one gives us 0x, 0y, 1z equals 2. So from this, we get z equals 2. That's one of our solutions. So then all that's left is to do some substitution to find x and y. So now we would use the second equation and see that that is 1y plus 5 over 3 times z. But we know z is times 2, right? Equals 7 over 3. That's the equation that you get from here. 1y plus 5 over 3z equals 7 over 3. Because this is like it. Okay, so we just need to solve this equation. So y plus 10 over 3 equals 7 over 3. Then what would you do to solve that? Minus the 10 over 3. So y equals 7 over 3 minus 10 over 3. You have common denominators. So all you do is 7 minus 10, negative 3 over 3. That equals negative 1. So y equals negative 1. So now we have two solutions. How do we find the third solution, the x? Plug it into the first equation that we have left. X plus y minus z equals negative 2. So I would have x is, we don't know, y is negative 1, and z is 2. So we just need to solve that for x now. So I combine these, and I get x minus 3 equals negative 2. So what does x equal? X equals 1 now. That was a crazy long problem, right? Y'all are like, thank goodness we actually have calculators. But we don't. We write our solution like x, y, and z, like that. So then our solution would be 1, negative 1, and 2. If you can catch that from there. All right. So I did put several problems in there. I'm not going to make you finish all of them, but I do want you to do at least one like this. You don't have to do them all because tomorrow we'll go over this some more. So look at your assignment and see what you can do. And then tomorrow we'll go over questions. Okay? Make sure y'all show your work. You can use your calculator to check it, but I want you to show your work because you're trying to solve this puzzle of how can I get this? How can I move things around to get that?
Possible transfer, Mrs. Sausage.